Record to. Cool. All right. Happy Thursday, everyone. This week, the topic was class components and legacy React, which, as you can probably guess by how little content there was this week, it is generally not that important. I guess the only things I would mention about class components is class components used to be the way that you did React. Like that's just how it worked when React was first released. And then a couple years ago, I don't remember exactly what major version it was, class components were sort of deprecated in favor of function components. So for the most part, I would say that if you're going to write any new React code, you should always use functional components unless you're working in a code base that deals with class components. So if you are in a job and they've been working on a project for many, many years, there's a possibility that there might be some class components in there. My guess would be that they're not going to exclusively work in class components, but maybe it's too much work to change them. And so you should be aware that they exist. But in general, like you will not find a whole lot of Stack Overflow answers about class components. You don't need to worry about it that much. Just high level, the difference between a class component and a functional component. A functional component is literally just a function. And at the end of the function, you return some JSX, some HTML content that describes how your component is going to be rendered. And inside of here, this stuff gets called every time the function runs. So that's why we use hooks, because hooks allow you to call a function that gives you access to your state. So when I do this to grab state, then this is running every time my function renders itself again, because we're just executing top to bottom. In contrast, class components, legacy components are literal JavaScript classes. If you're not super comfortable with the concept of a class, which I wouldn't expect you guys to be, a class is sort of like a paradigm of programming that is pretty popular in other languages. If you write any Java code or ever have in your life, like literally everything in Java is object-oriented. It has support for other programming paradigms, paradigms meaning like a sort of like a style of programming or like a philosophy behind writing code. Object-oriented programming means everything that I have is a class named something. So I can have an animal class, and then I create instances of this class, which are called objects. So if we don't use like the literal JavaScript class, then you've already seen objects in JavaScript because we have objects with just our opening and closing curly braces. This is an object literal. It's just a bunch of key and value properties, which is usually all you need. But as you get into more complicated programming, sometimes it's helpful to have classes that have data attached to them. So maybe this animal has a height, animal has a weight, this animal has a function, say hi, and when I call say hi, it does something, stuff like that. So that's what classes are. A class is like a blueprint for a thing, and then you create an instance of that thing, and you can use your instances all across your code. So in the way that a functional component is literally like it exists sort of just as a function that React behind the scenes is orchestrating all the hard work for you. When I call use state, I'm not doing anything. I'm just saying, give me this piece of state that I own. And then React does the hard work of figuring out, okay, which state belongs to this particular instance of this functional component. And when I return this content, what does that actually mean in real HTML? A class, on the other hand, sort of explicitly defines all of these things a little bit differently. So a class can have a constructor, which is a way of creating an object. So this is my blueprint. My blueprint has data associated with it, and it has methods or functions that it can perform. And a constructor is how I tell it, I want to create a new thing. So if I had my height, actually, I don't know. I'm gonna Google. No, I'm not gonna Google. I think I'm fairly confident in this. So let's say for this animal, we wanted to have our height and our weight. So I would accept two parameters into this constructor and then say this dot height equal to height, this dot weight is equal to weight. And then I can have my other function down here, my method called describe. And this is a function that is associated to any instance of this animal. Any instance of this animal class that I create will be able to call this method and do stuff with its own data. So this data will exist on every object we create, but it'll be different because it's owned by that particular instance. Whereas this method, they all have it. So when I describe, I can console.log, I am height inches tall and weight pounds. And so what I can do is, now that I've defined a constructor, when I create an instance of an animal, I have to give it a height and a weight. And so I can give it, I don't know, maybe 24 inches and 70 pounds. And then I can call my animal dot describe. And when I do this, it'll print out I am height, inches tall, and weight, and it'll sub in those values. I did this in a React project, so there's not a great way to do this. Let me create another file really quick. Temp.js, and then we'll open a terminal node temp. No, that didn't work. Oh, I think I have to go into my source. Oh no, I broke it. Height is not defined. Okay. I really have to do this? I think I'm missing something. I have not written a JavaScript class in a very long time. I think I need a this, actually. Yeah, that's what I need. So this is a keyword that refers to the actual instance of the class. So this method belongs to every single instance of animal. Every time I create an animal, it will have a describe. And similarly, because in this constructor, I am setting this dot height and this dot weight, they're all going to have those particular variables, those instance variables, but they're going to be different values depending on what I pass into the constructor. And so because they're different, I have to say this particular object that is invoking this constructor, I want to set its height and its weight. And then down here, this particular instance, whoever's calling describe, in this case, it's my animal. I want to get its height and its weight, and this should work. Cool. So this is what a class is and an object, like at a high level, not talking about anything too complicated. Does anyone have any questions about this? not like the keyword this, like just this whole piece of content. Okay, I'm going to take that as a no, but if there are questions, let me know. So with that in mind, we have our functional components, which are functions that we can call, which sort of assemble together a layout that we're going to use and we're going to render. So we call the function, we give it some inputs, which is our properties, and then we get outputs, which is our content. Similarly, we can create a class that extends components. So extends is a keyword reserved for object-oriented programming. That means this object is a type of this other thing. So if this class is a blueprint, then I can create another class that is a more specific version of this blueprint. It's still a blueprint. Maybe I create a dog class. Well, a dog is a kind of animal. It has a height, it has a weight. It should be able to describe itself. So I can create a dog that extends animal. And so now this dog will inherit this method. And I don't think it will inherit this constructor. I think what I would have to do, my JavaScript inheritance is rusty. I think what we might have to do here is say super height weight. Super is a keyword that says call the constructor of my parent's class, this animal. So we have a constructor, it accepts a height and a weight, and then we're calling the constructor of the animal, which will set height and weight of this dog. And I can do the same thing here. Maybe this dog is tiny. It's only about 5 inches tall, and it probably weighs like 10 pounds at most. My dog.describe. Cool. So this also works. This is a dog. It inherits all of the content of its parent, which includes its methods. And then we can call those methods because they are also a part of dog since we inherited them. So that's inheritance, high level, again. And so that's what's happening here. So there is a component class that React has defined. We can go look at it, but it's disgusting and is full of comments that are just documenting how it all works. And you'll notice there's a lot of depreciated tags in here, which is just to say, don't do that, do something else instead. We have better code for you to write now. So we can create a component that inherits all the properties of a React component. This is really important. And then we have our constructor, which again, we can accept whatever data we want. Maybe this is like a, I don't know, let's call this input with button. And we have a constructor that can do something. We'll leave it empty for now. And we have a render method. So instead of calling return at the end, which sends data out of our function, we declare a render function that anytime React tries to render our component, it'll recognize this is a class component. I'm going to call its render method. And so then here's where I would return my H1. Actually, let's do the whole thing. I'm gonna make this bigger since there's no reason to have my Notion up still. Oh, this is supposed to be an input. Cool. So this is our component. It returns some piece of content, which is our HTML structure. And if we have other components, we can use them in here, same as a functional component. I can call my component here. And in the end, functional and class components do the same thing. So I can still pass it properties. And I can still give it like a function as a property and call it from inside the function. We could do anything that you can do with the function component, you can do with the class component. And then there are some other differences that I don't want to get too far into because, again, you really just do not need to worry about this at all. There are no hooks with class components because hooks didn't exist at the time that class components were used. So there's no use effects, there's no use state. You can't use either of those with a class component. Instead, we have lifecycle events, which I'm going to Google because I don't remember the name of them. Let's look at this one. Nope, these are all functional components. React.component. Cool. All right, this is what I was looking for. So with class components, we don't have hooks. Hooks just allow us to call state and use state wherever we want. And we can have multiple use effects, which means we can have multiple different side effects that our code runs when certain things happen. Instead, with a class component, everything is a predefined method that belongs to components. And we're going to redeclare those methods and override them with the logic that we want our component to do instead. So a constructor sort of replaces like passing in properties, calling our function, or rather calling our components, in that we can use it to initialize data. And our render replaces our return statement. And other things in here, component did mount is invoked immediately after a component is mounted into the tree for the first time. So this is like a use effect with an empty dependency array, which if you'll remember means run one time when my component first loads and never again. That's what this did mount function is. So this is all the code that's going to run when your component is first inserted into the tree. One of the downsides of this is that with use effect in a functional component, I could declare like 5 of these. If I have 5 different things that I want to happen in the same event, in this case, when it first loads, I don't have to group them all together if I don't want to. I can separate them for readability and say, this is one effect that happens. This is another effect that happens. This is another effect that happens. Whereas with the class component, because it's predefined methods that exist in the component class and you're overriding, we can't define a method 3 times. You can only have one copy of a method per component. And so all 5 things that I want to do, even if they're completely different, all have to go inside of this method. So I would put this down here. Oop. And this is a method that we could call, then I could put any logic in here I want. So there's pros and cons. At this point, class components are obsolete, and so I don't really even want to talk about them anymore. But hopefully this at least gives you more of an idea of like what a class is, what an object is, what a constructor is, so that at least it makes a little bit of sense how a class component functions. Any questions about class components? Okay. Do we have any other questions about anything? If we don't, I have another topic we can talk about. But obviously you guys are first.
I have one question.
Okay, go ahead.
So like in class component did mount method, is there is another method?
There's another what?
Method like a component did mount method.
Yeah, there's plenty of them. I could post a link here for you guys that I was looking at. There's so many events that you can look at. So we looked at component did mount. There's also component did unmount, which is my component went away. One thing with use effects that you probably haven't had to use yet is you can clean up a use effect by adding a return statement that returns a function that does some cleanup. So let's say in my use effects, I'm running this when my component first loads onto the page, and I want to subscribe to some server that's just feeding me data all the time. One reason you might do this is if you have a WebSocket. A WebSocket is a way of communicating between a client and a server just continuously. You're just sending messages to each other, constantly listening, responding to them, sending messages back. You just for like real-time communication, or if like something is going on the server that you need to send information to the client. There's several use cases for it, but that's something that I want to create one time. I want to create that connection when my component first loads. And then when the component goes away, I want to clean up that connection. I don't want my browser to be using those resources anymore. I don't want to be receiving messages and acting on them. I'm done. I quit. I'm out. So you could do my web socket.subscribe. And then this would probably be a function that does something. And then down here in the cleanup, we would call my WebSocket.unsubscribe. And this would clean up all the resources that are being used to create that connection and stop listening. So this is something you haven't had to do yet, but is something that you'll probably have to do in the future. And with a class component, we have the method component did unmount, I think. Nope, maybe not. Component will unmount, called immediately before a component is destroyed. So I guess this makes sense. Did mount means I want to check that my component is already in the page. Like I know that it's there. I don't want to subscribe to some data if it's not actually going to render properly or it's not on the page yet. But you do want to unsubscribe before it goes away and React stops caring about it. So that's the reason why this is will versus did. So will unmount means right before it does. This is where I would do my cleanup here. The other thing that you might be interested in is, well, use effects. I can declare dependencies array in here. So when my state changes, I want to run this use effect. So let's see if we can figure out how to do that using the class component. This display name props. Render, I know. I think this is it. Essentially what you would have to do with the class component is, because again, it's a predefined method. You can't create as many use effects as you want because use effect doesn't exist. Instead, we have this function component did update, which is invoked every time immediately after we re-render our content. And it gives us the properties that it used to render and the state that it currently has. And I don't know what this snapshot is necessarily, but you can use as many of these as you want. In this case, this only cares about the previous properties. And so you would have to use this function in order to accomplish the same thing. You would have to do component did update, and then rev props, rev state, and then this dot state. You could check this. This is a property of this class, which holds the current state of this component. And you would have to check if this dot state dot my state, that thing that we expect to change, is not equal to prev state dot my state. So if in this render, my particular state variable has changed from the previous render, well, that catches the same thing as this use effect, where we're going to trigger this if my state has changed since the last time we rendered. And then you would put your logic in here. And then you would have another condition to say, else if this dot state dot my other state is not equal to prev state dot my other state. And you'd have to have like if conditions for every single piece of state that's changed, because they all have to go in this method. You can only have one. You can't have multiple use effects, which I think is the biggest downside of class components. I think this is disgusting. I think having a use effect, which clearly indicates this is a function that is going to run when this happens, and it's going to perform these singular isolated side effects. And if I have multiple different things that need to happen at the same time, well, that's fine. I could do something else and create another use effect. And these are both going to trigger at the same time, but they do totally different things. And so they're totally separate. I think it's a lot more readable. So another good reason for using functional components. Any other questions?
Thank you.
You're welcome.
Except the three life cycle methods of class component, anything like we should at least know about them. Important methods.
I think this is all you should really care about. When it loads, when it unloads, and when the component updates. Like these are the ways that you can do all the stuff that you've done so far with a functional component, just with different syntax. There's a couple of other smaller things. With functional components, our state is in individual variables. So my state here is an object, and I can have another individual piece of state called my number, set my number, use state 0. So these are two separate pieces of state. I can use them separately. I can update them separately. But we need a way for React to know what is state. But we don't have this hook to say, I want to create a specific piece of state, one individual variable. And so instead, with class component, state is stored in an object, this.state. As you'll see, it's already suggesting for me. So I can call set state, and I think this takes, I don't actually know how this works, to be honest. What is this first argument? Huh. It was showing me that there was another argument in here, but I'm not seeing it. Anyway, more or less, maybe the syntax isn't exactly perfect here, but we would call set state. And then here I could set my state equal to hello world, and my other state equal to 0. And so all of our state is bundled in an object together. If you remember when we talked about the reducer hook a couple weeks ago, it's very similar to a reducer or to Redux, if you've ever heard of Redux, where all of your state is just in a single object and you just use the properties you want. But in order to update our state, we have to set the whole object. So if I wanted to update this, I would have to say, or I can get my state down here by getting this dot state and then this dot set state. And do stuff like that. Question here, should we always define unmount return with use effect? If the user closed the browser, will unmount be implemented? You very rarely have to care about unmounting. Only if you have like a subscription that you have set up do you need to care. For the most part, anything related to your component is going to get automatically cleaned up once it goes away. Like any content that it's created on your page, any elements will get cleaned up by React. Any state data are going to get cleaned up. You don't have to worry about any of that. Only if you create something that React doesn't have control over, such as a subscription where you're listening in for data and then doing stuff as a result, will you have to clean that up. So it's pretty rare that you would do this use effect, or if you're using class component will unmount. It's very rare you'd have to do this cleanup over here yourself. The only time I've written code like this specifically was using WebSockets. Any other questions? Okay. What time do we have? 25 minutes. The other thing that I was considering talking about today would be some more advanced ways of using Git, specifically for like once you get into a bigger project and you're working with other people other than yourself. I don't know if we will get very deep into that, so that might have to wait for another day. But I do think we could at least start talking about maybe some sort of smaller things that could be helpful for you, even while you're working on your own. So what I'm going to do is I'm going to close this. I swear I have a desktop. Am I an idiot? This is crazy. It's not in here. Why can't I get to my desktop? Anyway, whatever. I'll just create it. I'm gonna create a folder really quick. Oops. My little brother. He's watching a baseball game currently. Cool. And then let me open this folder in my terminal, and I'm going to open this in VS Code. And while I'm at it, I'm going to open Microsoft Paint off to the side. So at this point, you guys have been using Git for a number of weeks. And at this point, I think you guys are probably pretty proficient at creating commits and pushing those commits to your repository, and then merging those back into your main branch and creating a new branch, which is great. So in terms of general workflow, things that we might do would be create, I'm going to create like a JavaScript file. Rather, we'll create a new Git repository here first, and I can't touch because this is not a Mac. So we'll just create hello world.js, and we'll create another file here called run function.js. So maybe this hello world declares a function called hello world, and this function logs to the console, unsurprisingly, hello world, and then run function just calls my function hello world. And if I were to run this, hello world is not defined because I didn't export it. So let me do that really quick. And I got to put this in curly braces. Since it's a named export, I want to be able to call it by name. So now if I do hello world, it'll auto import it for me. Cool. Oops. Oh my goodness, what did I do? Oops. All right. We're going to scrap this. We'll just make it one. So be it. I could create a node project and then I could export things, but that's overkill. All right. This time it's going to work. So we have a function, and this is our great program. We created a Git repository. We're going to git add, and we look and we see that it's green because it is ready to be committed, but it hasn't been committed yet. So I'm going to commit it and give it a message and say initial commit. And I don't have a remote for this that I can push to yet. But if I look at git log, this is the first thing we're going to talk about. Git log shows us all of the commits that together comprise our project. Right now, it's only one. I could make some changes here. I could declare another function, unused function, that does this, something else. And I can do git status, and I will see that it is also not in a commit, but it's ready to be committed. So I git add my run function, git commit -m, add unused function. Cool. If I go back into my git log, you'll now see that there's two commits this time instead of one. So again, you already know this. A commit is like a single unit of change that tracks how your code works. And if I start a Git repository from the very first commit, all of these commits contain basically a delta, which we say is a change from the previous commit to get to the state of the next commit. So this commit is a delta that says I created all of these things for the first time. That's all it is. I can actually check that, I think, if I do git diff. Actually, this isn't going to work. Yeah, that's not going to show me what I want. Ignore that for now. But this is a diff that says from absolutely nothing, add this file. And then this is a diff that says from this commit, I added my unused function. And so now if I apply both of those through some really complicated algorithm that Git knows, it gets me to the state of my code that I expect. And everyone has the same Git that applies the same algorithm and can get them to the exact same state. That's how Git works. It's just a sequence of changes that can get you to the right place in the end. And you'll notice that there's these really long numbers here. This is a commit SHA. I don't know what SHA stands for, to be honest, but it's usually a very long string of numbers and characters that is a unique identifier for this commit. So no other commit in my entire project will ever be allowed to have this same commit SHA. If it does, Git would be broken. And I can reference this just by a subset as well. I don't have to type out this whole thing if I don't want to. But if I want, I could check what is the difference between this commit and this commit. And I can do this by running git diff. This is a command that lets you know what changed between these previous two commits. Maybe I don't know exactly where I made a change that I'm trying to go back to and understand. Well, I can get the diff between a certain commit and another one to see, is that where my change came through? Maybe I'm trying to see, oh, where did I introduce unused function? Well, what I can do is I can run git diff, which if I do -h, it's going to say it's a command where I need to give it any combination of really complicated stuff. But the one we're going to use is this, which is 2 commits. So I'm going to get the difference between 2 commits. So the left one is the one that comes sequentially first. So in my git log, this one came first. And so I'm going to copy this SHA and say git diff, my original SHA, and my most recent commit. Oops. That's not going to work. Let me go back. Git diff, my original commit with a space this time, and my other commit. Enter. Cool. So it's going to show me that delta between those 2 commits. Plus means I added code. If I removed code, it would give me a bunch of scary red minus signs instead, which just means you deleted stuff. And so this is saying this is the old version, and this is the new version that has all these changes in it. What does a hard reset do? Great question. Let's talk about checkout first, and then we'll talk about reset. I would say that I use git diff, I don't know, maybe like a couple times a week. Usually it's very specifically to make sure that my commit only contains a certain number of changes. So what I'll do is I will write a lot of code that makes a very big sweeping change to something that I'm trying to do at work. But if I give a giant commit, which has like hundreds of lines of code that have changed, and I give that to someone at my work and say, hey, can you review this code to make sure it's okay? They're going to be like, no, absolutely not. That's too much work. Split it up. And so then what I will do is I will split up my commits into smaller commits that each do part of what I'm trying to accomplish. But I want each commit to be its own unit of change. So if I have 3 different files that changed that are all unrelated, well, maybe I commit the first file, which does something, and then I commit the second file, which does something totally different. I change something totally unrelated, and then I commit the third file, and that's 3 smaller commits. Well, if I want to be sure that my commit only contains changes related to it, or maybe I accidentally committed the wrong thing and I just want to double check, then I'll use a git diff to say, okay, what actually changed between these 2 revisions, between these 2 commits? And it's useful. You can do this through your IDE as well. Like you can use the Git integration, which will allow you to check out or do all kinds of other stuff. I don't see a diff command in here necessarily. But you could probably do the exact same thing from VS Code or any other IDE you're using. Cool. So that's diff. Typically, the way that you would see Git described visually is using something we call a graph. So in computer science, a graph is a data structure similar to an array or to a dictionary. If you've heard of a dictionary, a graph is like a sequence of nodes, which a node is just like some object that exists and it has some data and it points to another node. So if I were to create a class to represent a node, it's just a class that has a constructor and I can pass it data that it holds. And I will also typically pass it a reference to the next node that it needs to point to. So in a graph, we have one node that's connected to another node and then connected to another node. And so I might also pass it next and say this dot next is equal to next. And so now if I have a node here, I can say this node has value of 1, which we're creating this node right here. It has a 1 inside of it, which is what people typically do. They'll draw the content inside. And we'll say the next node is null for now because we don't have one. And then let my other node equal to another node. This one can have value 2. And this one will also be null. And then we can say my node dot next is equal to my other node. And now this node will point at this node. And so I can go from this node to this node if I wanted to travel through the graph. And so there's all kinds of like really complicated algorithms you can do with graphs. And we're not going to talk about any of that because it's not important. But just be aware that this is how Git is represented under the scenes. This circle here, instead of holding data, which is a number, it holds all the data related to a commit. So this is a singular commit. And then we have a diff that takes us from this to this. So this would be our initial commit here. And then this is our first commit. And then if I had more commits, I would create them over here. But for now, we don't have that. So again, this is a commit. It will hold all the data inside of the node, and it will have a diff. How did I get here from the previous one? In this case, the diff is I just created everything. The head is that initial commit. So a head is the start of our graph. It has to start somewhere. At some, it's not infinite. At some point, there's a head and a tail. Our head is the start of our graph, and the tail is anywhere that doesn't have something it's pointing to. So a linear Git history has a head of the graph and then a tail, which is the most recent commit. But I'm just realizing what you were asking me. Git refers to head in a different way. So if I were to look at this terminal here, and I were to do git log, which again gets us our history, you'll see this here, this says head. So I just told you that typically, like colloquially, if we have like a tree or a graph, a tree is just like a special kind of graph. At some point, it has to start, which is like the head of our list, of our graph or whatever. But with Git, they have a special like reference, I guess you can call it, that always points to the current state of your branch. So we're on our master branch, and the head of this master branch is this most recent commit. So this means anyone who's working off of this branch, the most recent commit, the most recent state of this branch is that this is the end of it. Now, what I could do is I can create another branch, which is what you guys do when you're creating an assignment. You create a new branch, which lets me work independent of our master branch. And then once I know that my feature is ready to go and it all works, then I put that code back into my master branch, which is when you guys open a merge request. And then your reviewer goes through and says, yeah, that's okay, go ahead and merge it. And then it takes all of your code and puts it back in. Well, if I check out this other branch and then git log, you'll notice that it says my master branch is here, but also my other branch. It has two, each branch has a head, an end of the branch. And in this case, this is saying the head of both master and my other branch are at this particular commit. So if I were to represent this, this is terrible. Let me use some text. Let me erase this if I can. Cool. So head of master, this is tiny. That big enough for you guys? I can make it a little bigger. Do 28. So this is the head of our master branch. It is currently pointing to this particular commit or this node. And then we also have the head of our other branch. And it is also currently pointing to the exact same node. I'm actually going to put it up here. Now, as you guys do for your assignments, I can create anything I want. I can make some changes to this code where I created this node class. Let's add that and pretend like I meant to do that. Git commit, add node class, and I do a git log. Cool. Well, now we have an extra commit that only exists on this branch. So again, linearly, this commit has to point to this commit, which has to point to this commit. And so this means that I have a new, is that the right tool? Yeah, I just made it too small. I have a new commit here that only exists in this other branch. And so this is our commit number 3, and this has all of our data this has the diff that adds that node over there. And so now our head for our other branch, which again, we're going to make bigger, 28. Our head for this branch is now pointing to this commit. But with that in mind, we can delete this one very carefully, since the head is no longer pointing up here. But our master branch still has its head pointing to this commit. So it's like further behind in our chain. And we could do this over and over. We can create like 40 different branches that are all sort of like creating nodes that are sort of outside of our main branch. In any depiction of Git, you will typically see that your master branch or your main branch, whatever you use, is like the linear, straightforward line here. And then our branches come out from the side and create commits that don't yet exist in our master branch. And once we're finished with them, at some point, I need to take this and stick it into our linear history of our master branch, which is what happens when you merge. So when you create a merge request, it takes all these commits that exist in your other branch and it throws them and sticks them in this line, and everything's fine and dandy. And your local Git is still saying, oh, well, the most recent commit I have is this one down here. But in GitHub, it's merged it so that there's new commits over here in the line. And so you're pulling down those diffs, which allows your local Git to move to the most recent version of your changes. So that's what happens when you git pull. It's going to download all of the diffs that got merged into your branch when you create a merge request. And then it's going to run that algorithm that moves between nodes and gets you up to speed. And you can create another branch from there, branch number 5, and so on and so forth. So that's like a really complicated way of what's going on when you submit a merge request. Eventually, you do need to merge. You can't just always create a new branch because otherwise, if you're working on a team, like if you just create a branch and do some stuff, and then you create another branch off of that, and then do some stuff, well, you're not doing Git anymore because that's now basically just your master branch. Like, why did you create a branch in the first place? You could have just done all of your work on the master branch over and over again, which you should not do because your master branch should only be code that you know is going to work. You should not have any code in your master branch that you are unsure of or you're still working on, because once you set it up to automation, where like when I push code to GitHub, I want it to start building and just deploy my code automatically to a server, your master branch has to be absolutely spotless. And so that you do all of your work on a branch, you take those commits, you stick them back onto the master branch by merging, and go from there. There's more complicated ways than just clicking the button in GitHub. One thing that if we had more time, I might have talked about is rebasing. It's just a different strategy of merging that has some other benefits. And even when you're not merging, you can use a rebase to do some really cool stuff. So maybe we'll talk about that in another week, but we're out of time this week. Really quick, last thing I want to mention really quick is Git checkout. So if I want to go back and just sort of see what my code was like during this initial commit, I can run Git checkout of this particular SHA, and it will tell us if I want to go back, I can run Git switch with a hyphen, or if I see that, oh, this commit is actually what I want, and I want to go back here and then create this new commit off of this branch. So I'm going to create a new branch with some code that I want to write that just builds onto this old commit. Then I could run git switch and create a new branch. But really, this is just so that you can go back and view what your code was like in the past, which was not a whole lot. This is also pretty useful, although you don't have use for it right now in your project. And then I can run git switch to go back, and it'll give me all my code back. we'll leave the rest of it. Git reset is another thing that you might use. Resetting is if you want to undo some changes in a commit that you already made. So let's say my master branch is on commit number 2 here, and I just created commit number 3, and then I committed it, I pushed it to my repository, and then realized, wait, I need to fix it. That's not right. I can reset to sort of pull apart that commit and still have all of my changes, but that commit no longer exists. So I don't lose anything that I wrote, but it gives me a second chance to create the commit. Which didn't make any sense. I don't think my explanation. We'd have to do it physically in order to show, but I'm not going to do that. I want to answer some questions really quick, since there are some. A hard reset and a soft reset, those are just two different ways of resetting. There's also a mixed reset. So a reset just takes your commit and sticks you back to a previous commit. So I can reset 1, I can reset 2, I can reset as many commits at a time as I want. I could git log, and then I could reset all the way back to my initial commit if I want to. I don't have to just go one at a time. A soft reset will I think it will unstage your changes. I don't actually know what a soft reset does offhand. I think it undoes your commit. No, I think it resets you to a previous commit, but it doesn't break apart the commit that exists. So if I'm here and I reset to here, it won't get rid of commit number 3. That'll still exist. Generally, you don't use a soft reset because that's like very similar to a checkout. A mixed reset says, scrap this commit, but all the changes that went into it, leave them for me. So in this case, git reset -- mixed of my most recent commit. If I go to git log, it'll show me that commit. Oops. Sorry, I got to reset back to a commit. So I'm going to reset back to the one right before, and it's going to say it unstaged these changes. So if I git log, that third commit no longer exists, but all the changes that were a part of it are still recorded. So I can still make changes to them and then commit them again if I want to. I don't lose them. So I can git commit dash redo commit 3. And then if I do git status, oops, I didn't add them. Do that again. Git log. All right, now I have them back. If I do git reset -- hard to this commit, then all of those changes are gone. It doesn't give them back to me to use. Every change that was in that commit is completely gone. That code is gone. You cannot get it back. That's not actually true. There's a thing called git rest log, which just lets you, like, if you really fucked up, then you can go back and retrieve something that doesn't exist anymore. But because I hard reset, it took me back to that commit, but all the changes that were in the commit that got scrapped are gone. I have no idea what they did. That'd be a case study. I wouldn't worry about it too much. Generally, if you have something that you know you don't want anymore, and you just want to do something differently, then you can hard reset. Or if you have something that accidentally found its way into a commit and is like somehow screwing up your project, maybe you have to hard reset to get rid of it. But I would say more often than not, you use a mixed reset so that you still have those changes that you committed. Because you probably want some of them, but not all of them. Stuff like that. All right, that's all I got. Sorry for running over time. If you have any questions, feel free to stick on. Otherwise, that's it. Happy weekend. Have a good Thursday. I'll see you guys next week. Should anyone delete a merged branch? I think that you can delete a merged branch if you are certain that you don't need it anymore. If you merge a branch in, generally you don't want it anymore. It doesn't matter because all the code is now in your master branch, and so everyone else can use it. So I would say more often than not, it's safe to delete it. It doesn't hurt to keep it around for a little while, just like in case shit hits the fan, which has happened before. Maybe like I accidentally mess up my master branch. Like I tried to pull down the change that got merged in and then do some complicated Git stuff. And somehow I lost that commit. I ran a command that scrapped it. Um, well, in that case, I might want that branch to still exist in GitHub so so that I can go back to that commit that I merged. Um, locally is the same. Like you can have your branch locally on your Git once it's merged in. In general, I would say locally it's more important to get rid of the branch once you're done with it because you actually see that all the time. If I run git branch, I want to make sure that the only things I'm seeing are things that I'm actively using or work that I haven't finished yet. Because especially once you start doing code reviews for other people, um, they all have their own branches they're working on, and you'll pull down that branch so that you can inspect on your local computer what the code looks like and maybe like test out some changes if you think they could do something differently. I'll write the change here and see does it actually work? Like, am I suggesting something that's real? And so those branches in particular, like they start to pollute this screen here. So once you're done with a branch and you're confident you're not going to need it again, maybe you let it sit for a little while if you're really like nervous about something, a couple days, then you should feel free to delete it. Any other questions? You're welcome. All right, I'm gonna stop the recording. See you guys. Have a good weekend.